So today we're pulling apart the Kramer BCLS-31. And I know when you first look at the spec sheet,
Yeah.
it just looks like a spool of yellow 6A cable. Seems pretty standard.
It really does. But the thing is, when you dig in, this is positioned as a very specific solution, especially for high-density installs.
Right.
Our mission here, really, is to see how they pushed the bandwidth all the way up to 650 megahertz in a UTPD design without making it impossible to install.
That's the first thing that jumped out at me, too. A 650 megahertz, that's way above the CC6 standard.
It is.
And usually to get that kind of signal integrity, especially when you bundle cables together, you're looking at shielded cable. But this is UTP, unshielded twisted pair. So how are they managing the interference?
Okay, so that's the aha moment in the engineering docs. It all comes down to something they call the zigzag jacket design.
I have to admit, when I first read zigzag, I got a little nervous. I was picturing a cable as like a serrated edge or something.
Yeah, that'd be a nightmare to pull through a conduit.
Total friction city.
Right.
Yeah.
But the outside is actually perfectly round, totally smooth. The zigzag is on the inner wall of the jacket.
Oh, interesting.
It's a geometric fix for what's known as the 6-around-1 problem.
Let's define that for everyone. That's what happens when you pack cables tightly into a tray or a conduit.
Exactly. You get one cable in the middle, surrounded by 6 others, and if those cables run parallel for long enough, the twisted pairs inside can align perfectly with their neighbors. That's when you get alien crosstalk.
The signal just bleeds from one cable to the next.
That's it. So this internal zigzag pattern, it gently forces the pairs inside out of alignment.
So it's randomizing their position relative to the cables next to them.
Precisely. It creates just enough distance and disruption that you don't need a foil shield, but you still kill the crosstalk. You get the electrical performance of a much more complex cable.
But it pulls like a simple, smooth, round one. That's a really smart trade-off.
It is.
You save weight, you save termination time because you're not dealing with a shield, but you don't sacrifice that bandwidth. Okay, so shifting gears a little, we have to talk about the material itself. The documentation makes a huge point about this being LSCH.
Low smoke, zero halogen. Yeah, and this is where we go from, will my network be fast, to, is this building actually safe?
And why is the zero halogen part so important here? Why is that so emphasized in the safety data?
It's all about combustion chemistry. You know, a lot of standard cables are made with PVC jackets.
Sure.
If PVC burns, it releases chlorine gas. And when chlorine hits any kind of moisture, like, say, in your eyes or your lungs, it can form hydrochloric acid.
Wow, so in a fire, it's not just the smoke you're worried about. The smoke itself is chemically attacking you.
Correct. And it absolutely destroys sensitive server equipment, too. This cable meets strict IEC standards, so it barely smokes, and what little it does release isn't toxic. That yellow color, that Pantone 116C, it's basically a safety indicator.
That's a level of compliance you don't always think about in just a bulk component. So really quickly before we wrap, what about the guts? Inside that jacket, is it standard 23 gauge?
It is. 4 pairs of 23 AWG solid bare copper. But they also include a cross filler, like a plastic spline, running down the center.
Which keeps the pairs separated to reduce the internal crosstalk, which is different from the alien crosstalk we were just talking about.
Exactly. And for any installers listening, yes, there is an internal ripcord for easy stripping.
Always a relief. So to kind of bring this all together, the Kramer BCLS-31 is really trying to have it both ways.
How so?
It wants the high-frequency performance of a shielded cable, which it gets from that internal zigzag geometry, but it also wants the easy handling and, more importantly, the safety profile of a smooth LSZH unshielded cable.
That's a perfect summary. It's a really holistic approach to infrastructure, you know, balancing data speed with physical safety.
It definitely adds some weight to what I usually think of as just a commodity item.
Well, it raises a question, I think. We obsess over our Wi-Fi bars and our download speeds, right? But how often do you stop and think that the physical pipes connecting everything are engineered not just to move our data, but to literally keep us from breathing acid smoke in a disaster?
That is a sobering thought for the next time you plug in an Ethernet cable. Thanks for listening to this deep dive.